How's it going, Geometry guys? Today we are going to look at 6.7 polygons in the coordinate plane. Okay. Quick review. These three formulas, muy importante, very important for what we're going to be doing. Distance formula. It's going to be used to determine if sides are congruent or if diagonals are congruent. Okay? And again, that's if you're given some point x1, y1, x2, y2. Okay? Same with midpoint formula. It's used to find midpoints. Used to see if things bisect each other. Okay? And slope formula. Let's see if they're parallel or perpendicular. Remember, parallel means equal slopes. Perpendicular means your slope is a negative reciprocal of your original. Okay. So let's do this thing. It's not easy to do these. Okay. But we'll get there. I'm not scared. DE half as vertices at 0, 1, 4, and 5, 2. And we have to find out what kind of triangle is this beast. Okay. Well, just by looking at, can you tell if it is scaling as isosceles or equal? Can you tell just by looking at it? Well, you can take a good guess. In fact, there is a shortcut way you can find out, but I'm not going to teach you that. So here's what we have to do. You have to find the length of each segment. So first, let's find the length of DE. Okay. Well, D was 0, 0, right? E was 1, 4, right? So we do our distance formula. Square root of bloop, bloop, minus squared plus bloop, bloop, minus squared. Okay. So I'm going to use my E in there first. So it's difference of my x's, difference of my y. See where I plug those in? Then it's my difference of my x's, difference of my y's. So I end up with the square root of 1 squared plus 4 squared, which is square root of 16, 17. And we're actually done because he can't simplify this anymore. We'll do something quick over this tomorrow so that way we get used to simplifying it. Alright, next let's find DF. Again, D is 0, 0. F is 5, 2. So I'm going to use the same setup. Square root of dot minus dot squared plus something, something minus something squared. Okay. I'm going to plug my points. Again, I'm going to use my F first. So 5, 2. Plug in my DED. Difference in x's squared plus difference in y's squared. So what do we end up with? Square root of 5 squared plus 2 squared, which is square root of 29, which cannot be broken down anymore. Well, at least we eliminated the fact that we know it can't be equilateral, right? Can't be equilateral. We got one more thing to find. EF. Okay, we know what E is and we know what F is. So I'm going to set up my equation. Something minus something squared plus something minus something squared. Okay. I'm gonna have F go first. So I do my 5. So I pretty much plug in my coordinates, right? X, Y. So it's 5 minus 1 squared plus 2 minus 4 squared. So we get square root of 4 squared plus negative 2 squared, which same thing, square root of 16 plus 4, which equals square root of 20. Okay? Which, and we'll talk about this, if you break that down, right, you get 4 and 5, 2 and 2. 2's make it out alive, 5's left inside, 2 root 5. Anyway. Are any of these sides equal? No, so it is scaling. Okay? So you have to do this to find the lengths of all the sides to see what kind of triangle it is. Okay, now we're looking at something. Looks like it's going to have 4 sides. M is at 0, 1. Gotta figure out where all this stuff's going to be. Negative 1, 4. Alright, so there's N. M. P is at 2, 5. And Q is at 3, 2. Okay, so let's play connect the dots. Okay, is this thing a rectangle? And right now everyone's probably going, no, it's not, Mr. Williger, no, 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 no. Okay. But we gotta prove it. To show it's a rectangle, you have to prove diagonals are congruent. That's the quickest way. Okay? So I'm going to draw on some diagonals. Okay. So that means we have to find NQ. And we're going to need to find PM, the nighttime. Okay. So NQ, we set up our distance formula. And let's see. N was negative 4, 4, right? So I'm actually going to put that second because there's a negative there. I always find that easier deal. That's just me. Q is right here. So we put in our 3, 2. So we get square root of 4 squared plus negative 2 squared. Hey, we've seen this one before. Square root of 16 plus 4, square root of 20, which is 2 square root of 5. Which again, we're going to talk about that stuff again, guys, because it's important. Very, very important. Okay, now let's find PM. Is that my equation? Oh, I'm using red. Okay, we'll do M in green and P in black. So P is the 0.25. M is the 0.01. Right? So we do square root of 2 squared plus 4 squared which is do 2 square root 20, which is 2 root 5. Okay? Okay. I forgot one thing. You prove diagonals are congruent and you have to show at least one right angle. Okay? Okay. So my diagonals are congruent. So that's step 1. Check. Let's use referencing. Check. Now we have to find a right. See if we can't find a right angle. So let's take a look at M, Q, P. Okay. So let's see. Well, how do we find out if these things are right angles? If you guys find the slope, you are correct. So let's find the slope of MQ. Okay, remember our slope formula? We use Q in red, our change in Y over our change in X. Okay, getting those from over here. M, change in Y over change in X. Okay, so that slope is 1/3. Okay, now let's find the slope of PQ. Okay, so PQ is right here. So it's our change in Y over our change in X. Q we're still doing in red. So we get 3/2 negative. Now are these negative reciprocals? No. So not right angle. Hence, not a rectangle. Or a square. Because they aren't 4 right angles, guys. Phew, it's a lot of work. Let's do one more for fun. A, B, C, D. A, B, C, D. Okay, we have this beast. We have this parallelogram. Not parallelogram, it's a trapezoid. And we want to connect the midpoints. Well, let's do the easy ones first. What's the midpoint BC? We go 1, 2, 3, 4. So half of that. That's my one midpoint. Okay. And my other one and this one is 8. Half of 8 is 4. So those two are easy, right? Now we have to find the midpoint of AB. Do you remember this formula? Here, we'll mark these guys in colors again like I like to do. Okay. You add up your x's divided by 2, add up your y's divided by 2. So 0 plus, 0 plus, 0 plus 2, these are my x's. 4, that's my y. Okay, so we get the point. 1/2. 2 is the midpoint. One half, 2. So I go to half, go up 2. Come on, Mr. Twillier. That's 1. Go 1, 2, midpoint. Now we have to find midpoint of CD. Okay. Same formula. M together divide by 2. M together divide by 2. Now what color should I make these guys? Here's C. Here's D. Okay. So I do. Oops. Oops, we're right in the wrong. Oh, wrong button. load already. C is 6, 4. Then we'll use, no. Then we'll use 8, 0. I clicked it. 8, 0. And we end up getting 6 plus 8 is 14 divided by 2, 7, 2. Ta-da! We made it! We found our shape. Okay. I'm actually going to end this one here because if I keep going, this video is going to be really long, and I tried making 15. We'll finish this one up in class, guys. Bring it in. We'll do this one. Sound good? Sound good. If you bring me in the answer, though, without me having to go through it, it might be worth a prize.